I'm going to go over the process of milling a PCB on the Modela machine. So first we start with PNG images of our circuit and the dimensional outline of our circuit. This one's a little bit special because it actually has dimensional cuts on the interior of the board. Generally it would just be this exterior shape. So we have these that have already been exported from EagleCAD. We're using Ubuntu and we're going to use the Fab modules. So we need to actually run these from the command line once they've been installed. So hit Control-Alt-T to bring up a terminal window and type the word FAB, and that's going to open up our Fab module selector. In the From format, we're going to select Image, PNG, and the To process, we're going to select the Roland Modela RML. Once that's selected, click the Make PNG RML button that appears, and this window should pop up. This window will allow you to, let me get closer here. This window allows you to do a number of things. First, you need to load the image that you wish to cut. Then you can select the width of the drill bit, or the mill that you're going to be using. So we're going to be using our 1/64 inch end mill to mill these traces out. Down here at the bottom, we're going to change the Z depth to 0.15 millimeters. And because we're going deeper with our Z, that's the plunge depth, we're going to actually slow our speed down to 3 millimeters per second. I'm going to adjust my X-min and Y-min. These are our offset values. I'll mention that a little bit later when I move to the machine. But right now I'm going to go with approximately 100 millimeters in the X dimension and 1 in the Y dimension for now. So once I have my settings set up, and actually you can't really see the Z setting, so this is the Z, negative 0.15 millimeters. Once I have those settings set up, I'm not going to touch it yet. I don't need to generate the files or anything just yet. I want to look at the physical hardware and see how that's set up. So this is the Modela machine, and there's several important features of this machine. We have the plate here. This is the base. We have the spindle where you would insert the bit. Here we have a sensor that normally is attached to this cover. The reason that we've got this tape over it is because we've taken out a metal piece that actually allows us to run the machine even with the cover off. And we have the power button, the view button, the up and down Z buttons. The power button, self-explanatory, it turns the machine on and off. The view button will put the machine in this orientation. This is the view orientation where the plate is very visible and accessible, and the drill bit is raised all the way and in the back corner. That's so we can change the bit fairly easily. Something that's important about this machine is that you can't actually send files to it or commands to it when it's in view mode. In order to send data to it, you have to push the view button again, and then the spindle will come down here to X0, Y0, which is the origin. And now I'm going to show you the plate that is removable. So you unscrew the two white screws at the bottom, and the top plate removes. Here we have our circuit board material. This is our copper clad board, and we'd like to use FR1 because it's paper based and it's easier to mill. It doesn't dull the end mills very much. And we have flat two-sided tape that we've attached this PCB to a sheet of green acrylic here. This green acrylic is sacrificial material. When we mill out the edges here of our boards, it's actually going to cut slightly into this acrylic. So it's good to have a sacrificial material here, otherwise we would be cutting into this steel plate and that would mess everything up. So we have the PCB material stuck with two-sided flat tape to the acrylic piece, and then we have the acrylic piece stuck with a two-sided flat tape to the metal plate of the machine. And if you look very closely, you can make out, let me see if I can focus it, a grid pattern on the black metal plate just through the green acrylic. That is for trying to align roughly your PCBs. So I'm going to place this back into its rightful place here and screw it down tightly. And I'm going to change the drill bit out. Right now, the end mill that's in there is not 1/64 inch. That's not the one that we're going to use to cut traces. So I need to replace it. So first, find the Allen wrench that you need, and you can spin the spindle manually with your fingers to make sure that the set screw is oriented towards you. Now there's a set screw on either side of the bit. So the bit's here, and there's a screw here and a screw there, or at least a screw hole on both sides in the spindle. There's only one set screw in there. So turn the bit until you find the set screw. So it's not that one, it's the other. And then loosen it and remove the bit. And be careful not to drop the bit straight down because it will hit this metal and it will dull the end. So now that we have that, we can replace it with our mill cutting end mill, or trace cutting end mill. And what I'm going to do is insert this about only to 1.25 inches, or only until 1.25 inches hangs out the bottom. And I'm going to tighten it fairly snugly, but it's just temporary for the moment. And what this is going to, try hard not to drop it like that. The tip seems fine. But what this is going to do is, by having the end mill deeper than I need right now, only by a little bit, only by a few millimeters, it's going to give me some slack whenever I go to align it. So now the end mill is in place, and I'm ready to move the drill bit to the offsets for my X and Y before I begin my cuts. So to do that, you must take it out of view mode, and it will automatically go to the 0, 0 point in this bottom corner. And now it's still in run mode, so I can send it commands. In the software, I'm going to click move to X-min, Y-min. And what this will do is make an offset of where the tool currently is. So it's currently at 0, 0. So I click this. It's going to drop the drill bit in the Z-axis just a little. And then it's going to move to my XY position. What I'm looking for at this point is to make sure that this bit is going to clear my previous milled spots. I want to cut a fresh, clean PCB. So I've done that. Now I'm going to set up the exact height for the Z-axis. So to do so, I'm actually going to drop this down a bit so you can see what's going on. So there is currently about 3 millimeters from the bottom of this end mill to the top of the PCB. I'm going to loosen the spindle, and I'm going to allow the mill to sit just with gravity directly on top of the PCB, and then I'm going to tighten the set screw back to be snug again. What that has done is set my Z-axis for the end mill. So now that I've got my Z-axis set, my X and Y coordinates look good. I go back to the software. I'm going to double check all of my values. So I have my Z value, negative 0.15, that's correct. I've got my offset, X min, Y min. That looks correct when I look at the board. It's not going to hit the traces of other circuits. And I have my speed at 3 millimeters per second. I also have my mill traces with 1/64 inch bits. So that's exactly what I have in the machine right now. So we're going to click the make.path file. This has created the tool paths. It's taken into account the width of my end mill, and it has generated the appropriate tool path. So now I can click on Make RML, which will make the actual file that gets sent to the Modela. Once I'm ready, I can click Send It, and a new window pops up, which gives me my dimensions and an approximate time. And I have this button here at the bottom, Begin Milling. When I click that button, it will send the commands to the mill, and it will start milling the board. This button will then turn into an abort button. If anything were to happen, I could click the abort button, and it should stop the mill. However, the mill will continue to cut whatever the last command was until it was done. So for instance, if it was cutting a long line from here to there, and you aborted halfway through, it's going to finish that cut before stopping. That's not very useful if you're breaking things. So I suggest turning the power off on the machine if you notice that something bad and dangerous is happening. Then you can abort. Just know that when you abort and you close this window, when you abort, the drill bit will actually go back to the 0, position. So you have to go to the other window and click Move to X min, Y min, and then send it again. Then you can mill from the same place, hopefully without damaging anything else. So I'm going to click Begin Milling in just a second. But first, I want to come back to the Modela and place the cover on it. So now the machine is ready to work. I'm going to click Begin Milling. And it should start cutting. Okay, the PCB traces have been milled. So what I'm going to do is push the View button, and that's going to bring the PCB forward. I'm going to remove this case and vacuum up some of the dust. You could check the traces. It's okay if there's burrs and things like that there. But now I need to cut the outline of the board dimensions. So I'll need to change back to the 1/32 inch bit. And to do that, again, twist the mandrel around until you see the set screw. And it's smart to turn the machine off whenever you are touching the part that moves. So I'm removing this bit. Replacing it in the tube, and I'm going to put in the other bit. And again, I'm going to have about 1.25 inches or so sticking out the bottom. I want to have some room for the bit to drop down whenever I get it set back up. Turn the machine back on. And take it out of view mode. And this is what the software looks like after it's run a complete cycle. You can see that all the traces here are red. So I'm going to click exit, and I'm actually going to remember what these values are. 100 for my X min, Y min is 1. And I'm going to close this, and I'm going to run my fab module again for my cutout of the dimension. So I select image to RML. I'm going to load the PNG of the cutout at this point. I'm going to select the 1/32 inch bit. For my cut depth here, this time I'm actually going to increase the cut depth quite a bit. It was the default is 0.0 or 0.6. I'm going to change that to 0.68 because our boards are a little bit thicker than that. I'm going to make sure that I adjust my speed to 3 millimeters per second. If you don't do that, it will cut and leave nasty burrs everywhere. I'm then going to put in 100 for my X, and Y is a 1. Those are my offsets. And I'm not going to touch it again until I'm ready to cut. So I'm going to go back to the machine and set up my dimensions. So actually, I'm going to move to X min, Y min first. Sometimes when you hit move to X min, Y min, the spindle will turn on and it won't turn itself off. The way to turn it off is to just click that button again, move to X min, Y min, and it will turn the drill off. So now I'm going to hold down the tool down button. The spindle will start up again, but the Z-axis will move down. And I'm going to stop about 2 millimeters from the top of the PCB, so you have to watch it carefully. Okay, so now I can loosen the bit and allow it to rest naturally with gravity on the top of the PCB. And then snug it back tight. It's ready to cut. So I'm going to come back to my software. And I have 0.68 here, I have 3 millimeters per second speed. I've got an offset of 101 in my X and Y respectively. I'm going to click Make Path, and it's going to create the cutting path for that tool. If you select the wrong bit, this will actually be a thick line, much thicker than this. And I'm going to select, you can move it around here. I'm going to select Make RML. I'm going to select Send It, and then I'm going to click Begin Mill as soon as I replace the cover. So I'm going to replace the cover here. And begin mill. It's actually going to cut deeper this time with each pass, so expect a lot more dust, and just listen for tool chatter. If you hear tool chatter, you can turn the machine off directly with the button on the machine, or actually click the abort button on the computer. So I click begin milling, and it's going to begin here in just a second. So we've got our boards all milled out. The problem is it didn't cut all the way through on this dimension. If we turn it over, we can see that it only cut part of the way through here. And this is the tape that was the two-sided tape sticking it to the bed. And here you can see a couple more where there's just a faint outline. So what we're going to do is cut those out using a razor knife. And so start from the front side and trace the dimension cut. It helps to hold the knife the right direction. And now we have a nice outline on the back, and we can trim up the corners. So there we go. So there is our circuit board, but it's kind of rough around the edges, especially that back side. So we have some tiny files that we can use to clean it up. So what I'm going to do, the burr is on this side. I'm just going to file the opposite direction. And you do that all the way around, and you'll have a nice smooth board. Now if you happen to have burrs in the center of the circuit, what you could do is take a steel rule and hold it perpendicular and rub it across the traces back and forth until the burrs go away. Now this is an interior cut here that didn't make it all the way out, so I'm actually going to have to work on that a little later and then use a round file to file inside there. But once you're done filing, you should take this and wash it with soap and water, because my finger oils getting all over this copper trace here will eventually oxidize the copper and eat it away. So you want to wash all the oils off of it, and be sure not to touch it with your skin afterwards. So you can use a nitrile glove when handling it for soldering and whatnot. And then as you see here, solder it in a vise or helping hands or something of that sort. And once it's soldered, you can coat this with some kind of material. I haven't done it just yet, but I've been planning to use fingernail polish, which will make a nice solder mask. So try it out and see how it works for you, and we'll post how it works for us.